Hello friends, welcome back. Today we are doing one more interesting tutorial about the most commonly used terminology in security. It is called OAuth 2.0. Today we'll find out what we can do in OAuth, the basic authentication and authorization mechanisms that we can do in OAuth. So there are several authentication mechanisms or authorization mechanisms. They are like authorization grant flow, implicit flow, and then you have a implicit form submit flow, and then you also have a PKCE flow, which is an advanced flow. So generally you are aware, I think most of the Java developers use authorization grant flow and also the implicit flow based on the scenarios. So we'll go through one by one, and at the end we'll discuss the merits of each other and what is the best path approach. So let's go ahead and initially let us try out the authorization grant flow, and then we'll do the implicit flow, and then at the end we'll do the PKCE flow. So let's go ahead and let me check I have created a sample project for authorization grant flow and the implicit flow. Let me check my Java version. We need Java 1.8. So my Java is set to 1.8, and now I am in my OR2 example directory. So let me go ahead and run this project. So while the application is starting up, let me go ahead and show you the project structure. So basically this is a simple microservice, Spring Boot microservice, which uses a user MySQL, which connects to a user MySQL schema and does some operations like retrieve a user, update a user, delete a user. I have a user object, and then I have a user DAO and a user controller. At this point I'm not doing much with this because we are more focusing on the security part, where we are going to authenticate, authorize, and then try to generate a token with which you can access the microservice endpoints. So let me take you through the application YAML. This is my data source, and then I have the client ID and secret. Basically this is the authorization credentials. But the best practice is to encrypt them and then store them using or you can use different kind of cloud-based encryption mechanisms. So that's up to you, but the idea of this project is to demonstrate how we can implement authorization grant flow and implicit flow and PKCE flow. So there is a redirect URL that you need to use, and then the authentication credentials are here. You can put them to anything. You can also go back to a web service that authenticates the user. So the validity of the access token and refresh token are mentioned here. Access token is around 60 seconds and refresh token is around around 30 seconds, I think 36 seconds. So now let's go ahead and check what we have. We have a basic Spring Boot application, and then we have let's look at the authorization server, which brings the client ID and client secret. This is specific to each application. There is a client ID and client secret. Basically, let's go back to the initial screen and do some basics. So if you go back to, let's take the help of this particular web page, where third-party web page, where they are mentioning what is authentication, what is authorization. Authentication basically checks who you are. Basically, you are asked to enter your username and password and verify your identity. So that is called authentication. Once you are authenticated, like you are able to log in using the user ID and password, then the application will check whether this user or you as a user has access to a particular web service or a microservice. So that is called authorization. So during authorization in our Spring OAuth flow, we will use the client credentials which are specific to each application, and your user credentials, basically who you are as a user. And once you log in as a user, what can you do? Can you access the user schema? Can you access this user some other database? So that is what is the gist of it. So let's go ahead and check, go through the authorization server configure after. Basically, you have the basic configure of method, and basically it is saying it is in memory, the client ID and client secret, and it has access to this authorization code flow and the password flow. It can also give the refresh token, and it is mentioning a scope, and it has a redirect URL. The validity is also baked in. So now the resource server configure adapter basically checks basically it says that you need to authorize such and such requests that are matching this path, and then you have the OAuth server configuration that extends the web security configurer adapter, and this is where you are actually doing the authentication, and it says for these paths you need to authenticate, and then for any path you need to authenticate, and for these you need to authorize the requests, and you need to override this for doing the authentication. And they have defined the CORS filters. Basically, CORS will help your application to go through the networks and everything, what is allowed and what is not allowed, you are mentioning there. So this is the application, basic Spring Boot security boilerplate code. So now let's check whether the application is up and running. So the Tomcat has started, the web server has started. Now let's check the implicit flow initially. So I have already put in some Postman scripts. I have saved them so the implicit flow is the simplest of them. So what you have to do is you just whatever the user enter the username and password, you put it in the body and put the grant type as password. It can also be called the password flow. And as authorization, basically whether this user is requesting to which resource, you are providing the client credentials. So whether he has access to that particular client or not. So once I go ahead and submit the request, I get the access token, refresh token, and expiry date. So this is the implicit flow, very simplistic. Now so the problem with this particular flow is that anybody like who gets access to these values can easily go ahead and get access to your application. So OAuth has provided another flow where you can make it a little more difficult for any person, malicious user who is trying to grab these credentials from your request. So it will make it a two-step process. So this is called the authorization grant flow. So now let's go ahead and check how does the authorization grant flow happen. So in the authorization grant flow, for our convenience, I have put the URL here. We'll just copy this and I'll paste it in the browser. Basically what we are passing is we are passing the client ID and we are expecting a code. So the response type is a code and the scope is user info. Basically we are trying to access that user info resource. So it takes me through to a sign-in page. It is very similar to the Google sign-in page where they are also implementing the authorization grant flow. So as you can see, once your username and password are matched in the Spring configuration or any web service, it gives you a code. So you use the code, like it's a two-step process. So anybody now has to get hold of the code. If you don't have the code, the request won't go through. So it makes it more difficult for the malicious user to be able to access your resources. So now we copy the code and send the request, and there you go, we have the access token. So now this particular flow is useful when you are talking between two particular servers that are within the same network. So the communication happens within the server between the two servers, so it is more secure. The chances of anybody spoofing the server network is very low. So this is specific to this kind of a setup. But if you are communicating through a single page app, and that means that the code resides on the uh, web browser, and anybody who gets access to this code also can try to access, and has access to the client credentials, can also try to access the resource. So this particular thing is also not that secure. We have seen many people implement this in a single page app, which is not actually secure. It makes it a little more difficult, but it is not totally secure. So OAuth 2 recommends another kind of authentication mechanism, authorization and authentication mechanism called the PKCE flow. Now let's go and see how we can quickly implement a PKCE flow. I have put together sample code where we can implement a PKCE mechanism. So for that we need to so right now we are using Java 8. We need to upgrade to Java 11 or higher. So what I would do is I will edit my bash profile, and set my class path to Java 11. Okay. I have updated the bash. So now let me reload it so that I don't have to restart my terminal. So now let me check my Java version. So now it is set to 11. So I have another sample project where I am able to put together the PKCE POC, proof of concept. So let's go into that particular PKCE project. So let me quickly go through. For convenience, I have put down the URLs here. It is a sample Spring Boot application. I have not put anything in the application properties file. Everything is within the Java class files. You have a web security configurer adapter. Again, if you remember, this is for the authentication. Basically, it is looking for the username John and password called pass. You can also go back to the web service and authenticate it. So, and you need to override this method here. Don't forget that. And there is one more method called authorization server configurer adapter. It is using some helper methods called PKC authorization code services and PKC authorization code token grantor. These are my custom methods, and there are a lot of Spring specific boilerplate code, and we are again overriding the authorization configure method with the overloaded with the authorization server security configurer, and also authorization server endpoint configurer object. So, and you are saying that you need to provide all these grants type refresh token, implicit token, client credential token, resource owner password token grant, PKCE authorization code grant token grantor. This is the most important one, and I think they are using the composite token grantor. And then the another configure object configure method, which is overloaded with the client detail service configurer. So basically you are saying that you are authenticating with a with two different clients. I think we'll just go with one of them. I just referred to this code that is available on the internet, but you could do whatever you want. What you could refer any other thing. Basically it's mentioning a redirect URL, and the code, the authorization grant type is authorization code. And these are like pretty much the boilerplate code that you need, where this is the PKCE protected authentication. token, this particular method extend authorization code token granter. I think it is trying to verify the code verifier that we are sending, and then we have another method which implements authorization code services. Basically, it is verifying what code challenge method we are using, and yeah, and then this one is generating the code. And if you look at the code challenge method, you will know that it is using one of the SHA-256 or the plain ones. Okay, and the plain one doesn't use any encryption mechanism or SHA-256 hashing. It just directly uses the code verifier. That is the high level just. So basically what it says is, if the user is using plain code challenge, it will directly use it to verify it. It will not transform it and check it when the user comes back with the same code verifier without hashing it. And but if he sends a URL parameter called hashing with SHA-256, then what he would do is he would try to check whether the user is sending the hash, and then whether that particular thing matches the code verifier. So that's all it is doing. So now let's go back and start our web application, start our service. Okay, our application started, and we will execute certain steps before we verify what is happening. So we have this URL where we are passing the client ID as public, and then we are saying that this is the redirect URL and we need the code to log into the application. So we'll copy that, and then we will do this, and then says it is using a authentication page. As you saw earlier, we were using John and pass as a username password. Try to log in, it comes back with the error description, code challenge required. So basically this particular PKCE expects a code challenge. Code challenge is nothing but a let's check what PKCE code challenge. PKCE Yeah, so PKC code verifier is a cryptographically random string. Basically, it's a random string, and it needs to have capital A to Z, lowercase a to Z, 0 to 9, and punctuation characters like hyphen, full stop, underscore, and tilde, and between 43 to 128 characters. And if you can generate any string using these characters. So that is what they are saying. So once you have that, let's see what is a code challenge. So once the client has the previous code verifier, which is generated using those particular alphabets and special characters, it uses that to create a code challenge. Basically, it is doing a SHA-256 hash of that particular code verifier string, and then it is doing a base 64 URL encoding of that particular hash. So as simple as that. So it is performing that, and it is sending it to the server, OAuth server. So we could use directly the particular code verifier like this, and it is giving you the code which you can directly use, or you could also use it to do SSH 256 encoding. Okay. Generator. So I think there is an online PKCE generator tool. Once we copy, sorry, this is something I quickly picked up from the online tutorials. So you can generate your own thing. So this is the code verifier. Code challenge, sorry. So this is the code challenge. So this one is giving us a code. Let's check if this works. Okay. So we want to put this back. Sorry, we'll go to the PKCE flow. Yeah, it says invalid land for this particular code verifier. So the user will send this particular code verifier to the backend. Along with the client ID and grant type and the code, right? So we copied that code verifier. So let's use this. Code verifier. We need a code challenge. So this is the code which we'll use here. Sorry, I think we need to use this guy. So let's go and use it. It has given us a code. Let's go to the Postman, copy our code, and the code challenge is this. As you can see, we got the access token. So friends, today what we have seen is we have seen how we can use authorization grant flow in a server to server kind of communication. We have seen implicit flow, which is even more simplistic, which is for secure communication between applications that are deployed on the same server. And then we have also seen a PKCE grant flow, where the communication between a single page app and then which is on a browser, and then it needs to access a resource on a web server, secure web server. There we need to use a PKCE flow. There are other ways. There is a implicit form submit flow that is also secure, but PKCE is the recommended one. There are other ways of authentication between different applications. You could use licenses, you could use biometrics. Multi-factor authentication is another very very robust way of authenticating. Today we use multi-factor authentication, like two-factor authentication, three-factor authentication, which is very common pretty much nowadays. So that is the best practice. So friends, today that's about it. Please don't forget to like, subscribe, and keep following my videos. Thank you so much.